Hi everyone, my name is V. Weiss, also go by Veronica Weiss, and welcome to my talk, Is This Magikarp a Gyarados? Using machine learning for phishing detection and talking about the interplay between the two. So let's just start off the talk with, who am I? I'm just a college student who really likes gradient boosting and Pokemon. And this past summer, I've been working on cloud application security, really dealing with credential compromise type of tooling, which is really funny that Capital One happened because, hey, what better way to show your value than an actual attack happening? So I've worked on data science teams in the past, security operations teams in the past, and this work kind of was inspired because I noticed a lot of workflows being not fully automated, which then got my interest in more machine learning and how to automate more of your workflows as a security operations team. And then I also was working for a computer vision lab for Skidmore College and MIT this year that really introduced to the more visual part of data analysis. So let's get the elephant in the room out of the way. Sometimes you click on a harmless link and it's like a Magikarp using Splash. And then sometimes you click on a link and it's hyperbeam.exe is downloaded and your IP address is somewhere that's not just your personal ARP table and some attacker has your network information. So that's just a quick way to describe phishing to some millennial kid if they don't know what that is. So the agenda today is a brief history of phishing detection that goes into the current state of research, the data collection process if you're an independent researcher who wants to get into this, what some data processing and feature extractions that you could also do on that data, and modeling and evaluation, as well as a conclusion. So motivation is that I was just in college, wanted to do a machine learning project. I was thinking about maybe taking ELF files and looking at header data. And then my professor thought that was too ambitious for one semester. And honestly, matching file signatures in the year 2019 is kind of outdated. So phishing is pretty cool. It's a nice, legitimate business case. So, but the issue is as a college student, you don't have an institutional college phishing repository accessible to you. If I was some security analyst at a big financial institution, then I would be able to just ask someone for some phishing emails and would be able to get some. But as a college student, you are kind of just thrown into the abyss as the internet and your brain as the only tools you have. So just thinking about phishing, I have some friends who are really smart at security, but they were asking me, why phishing? Like, can't someone look at an email and say, hey, I can tell that this is fake or not? But let's think about the vast audience of people who aren't accustomed to always thinking about what they're clicking on or thinking about how they're using the internet. So if you're just an employee, low level, you're thinking about just your day-to-day operations, and you get an email from your CISO saying, hey, like, update your credentials, it's mandatory, it'll look bad on you on your personal account with your manager if you don't update your information. Of course, you're going to click on a website such as this, see that looks pretty legitimate, and then boom, all your iCloud credentials are stolen. And now people can go look at your weird dog pictures that you've collected for many months. So that's really important to just think about as security professionals, we might think something's basic, but what about just a normal person? So common phishing attacks that happen right now are just DNS cache poisoning attacks, where an attacker can compromise a DNS cache server and then redirect to other IP addresses, or a malicious open redirects. This is actually using the JavaScript and HTML itself to have a redirect to a different website or a malicious attack. And then a botnet, of course, everyone knows what this is. It's just having your host be compromised as a larger attack surface too. So how has phishing detection been done previously, and how has it changed at all? So before, there were blacklists and then whitelists. And that's just a lot of manual effort. It's not scalable. A security analyst has to maintain this. And it also is based entirely on previous incidents. When you have larger people, like full phishing campaigns targeting your security team, especially if you're a smaller institution, you cannot just rely on static retrospective work. And that's why I think automation and machine learning can be really helpful to solve this issue. So a more new way of phishing detection has been human-driven and machine learning-driven. And it's really great if you could build out your own machine learning detection, but as security operations teams, you usually have to buy a product instead. So this is the small part of the talk where we talk about products. Sorry about that. But Cofense is human-driven phishing defense, which has human analysts observing phishing emails in real time, looking through your email repositories and kind of asking, hey, is this phishing or not? Behaviosec, Agari, and Inky are all companies right now that are pretty prevalent. All are in Series A funding or better, and they rely on machine learning in a various amount of ways. Behaviosec uses user behavior analytics, which we'll talk about how that's kind of a little suspicious to just depend on weird user behaviors that you may or may not actually have to be detecting to detect fraud. Agari uses ML as well, but they don't really like to share their solutions. Inky is based on a textual analysis using NLP, a visual analysis using convolutional neural networks, as well as other probabilistic modeling that they use to extract features from the email directly. So that's just some ways that if you're a security operations team, these are some good products that you could use, more so Inky. And so we were talking about behaviosec and behavioral metrics, but in machine learning, a lot of products right now are looking at the way that users type on a keyboard, the ways that they swipe on an iPhone, and that just kind of, to me, seems like a little intruding on people's personal information and confidentiality. And hopefully at Ground Truth, people have been talking about collecting the right data to prevent cybersecurity attacks as well. So if you're a company that kind of depends upon combating fraud, but you're also looking at people's scrolling techniques, like that's exactly what Tinder uses to like see and boost their metrics, like you probably don't need that. That's kind of uncomfortable information that's slightly dystopian to have as well for your employees. So what if we had a better approach that was scalable? It wasn't all based on a retrospective approach. It was more automated and had relevant information where you didn't have to just store extraneous information about people and their daily habits. So detection the right way depends on two data sources, emails and websites. So to dynamically evaluate an email, we'll go into that, but also we have to now be able to dynamically evaluate a website as well. And so this talk will go into what's been done before and the ways that you as an independent researcher can go into scraping phishing emails off the web and build your own phishing repository. So heuristics for an email, this is just a phishing email. As you can see, like you see the text, you see the paragraph, you see just the colors, the space, the way that white space plays into this email. And so the right way to look at this would to have an NLP-based textual analysis, as well as a visual-based analysis that will be looking at the coloration or seeing anything that's odd. Because as a human, we can look at an email and see, oh, something's off. We need to be able to also teach machines to do the same as well. So standardization for email classification should go upon 8 different categories, which are actually 7 categories. That is a Bitcoin cryptocurrency extortion scam. A lot of phishing emails right now are talking about ICOs and saying, hey, like if you reply to this with a certain amount of information, we'll send back some Bitcoin wallets or Coinbase account information. And that's just not, so that should really be like a prevalent category that is talked about in an email classification scheme, as well as if emails are from a disguise as an educational or a banking institution, or if emails are disguised from an application or help desk type of person who is asking, hey, update your account, click on this link to update your account. Those are also really prevalent and should be accounted for as well. And 419s are sometimes called Nigerian prince emails. That's when someone sends, hey, I'm in dire need of help, can you come send information back? And those are obviously bad and should be accounted for as well. And malicious PDFs are becoming more and more important as DocuSign and electronic emailing can really target executives and people who aren't really trained on how to use the internet safely, but are very powerful. And then, of course, we want to have a phishing, non-phishing email group as a control group, too, for our classifiers. So websites can be broken down into 4 different parts: a URL, the deployment of the website, the content of the website, which also includes the written content, the structured text, the HTML, and the JavaScript itself, as well as the reputation, which we could use certain algorithms like PageRank to determine. So now let's just talk a little bit about data collection, the feature extraction process, and modeling. So there's such a lack of phishing email data sets, and that's probably because researchers in academia do not have access to corporate and institutional emails. And it's also really hard to anonymize that information once you even have that, because you want to promote the integrity of the email as well for your classifiers, but still really hard to anonymize data. Thankfully, certain services like Google Cloud has a data loss prevention API that can be used to help deal with anonymization if you're interested in this work, and that's one recommendation for that. And so part of a phishing data set too is what are the prominent features of phishing data sets? What are we going to look at? And there needs to be more of a discussion in the machine learning community about, hey, are we going to look more at the URL? Or are we going to talk more about the JavaScript? We really need people who are going to be having a deep dive and, hey, we have these features, they're important, let's talk about the correlations between them instead of what exactly are the prominent features. So the Enron email dataset is a really interesting dataset that is from an energy company in 2002, and it can be used as a control group of just regular phishing emails. What happened was that an academic person from Amherst College purchased this email server for about $10,000, and now it's being used for academic research. The original copy was about 16 megabytes, and now it's much shorter, thankfully. But if you were interested in having some phishing research, this is a good data set to start drawing off of. I've used it before for the classifier that I'm building, and it's a really good place to just have a base control group. So public phishing repositories are also really good to have and know about. Cornell, UNC, Texas all have their IT departments give out different phishing repositories, and it's really easy to scrape the two off of it. And I'll also be putting on GitHub like the tools that I've written of using Selenium and Docker to scrape phishing repositories. As long as you have VMware, a file system that you want to write out to, it could even be just a file system or a PDF that as long as you can draw and make an analytics base table off of, then you can use it. And so this will be going up on my personal GitHub soon. If you don't want to have to write your own Python scripting, maybe you don't know how to write Python. And so that'll be up in a bit too. So the phishing website datasets that do exist are one from Mohammed, McCluskey, and Thabta. It's probably the most comprehensive phishing website dataset, and it has about 11,000 instances. All the values are also binary categorical data, so it's all one-hot encoded values, which is really good if you have some rule-based decision sets or a decision tree such as C4.5. You'll be able to have some nice splits because of the binary categorical data's nature. And the data set is split about 43 to 57, so you won't have to jitter too much or change the data. So now let's talk about just what the Mohammed, McCluskey, Thabta did to talk a little bit about what it means to establish finding extraction from a URL. So important things to think about for phishing and detection in a URL is the IP address in the URL? If so, it's probably harmful. The length of the URL, if it's 75 characters or not, then that's probably going to be more harmful. If there's an HTTPS token added manually to the URL, that's also going to be harmful, of course. If there's 2 forward slashes in places it shouldn't be, or if there's a presence of an @ sign in a URL, that's probably suspicious. An @ sign can be used to get away from browser mitigations, so it's really important to kind of look for these miscellaneous tokens that could be suspicious. And then this data set also has it included in their data, so then you could put this into a classifier and see the correlations and relations, as well as the frequency that attacks like this happen in their data sets. So now we can move on to deployment, which would just be talking about, is the issuer a certified trusted issuer of the HTTPS certificate? Are any ports open? And if so, which ones? How old is the website? And if the website has a DNS record or not? Also, really slightly small things on the website, such as the image itself. In the address bar could talk about if it's from a different domain and if it's harmful or not then. And so then we can move on to the content itself, which is looking at if an iframe was used. And an iframe, if you're not familiar with HTML, is a way to embed a web page inside of another website. So then you would be able to, in a subtle way, visually be able to go around someone seeing a website inside a website, so that would be harmful. Seeing if the website disables the user from right-clicking, you can just use a basic JavaScript to disable right-clicking on a website. If that is the case, then that's probably harmful as well. Also, if the website asks the user to submit information to an email address or using mail to or trying to have any client-side mailing systems, those are probably going to be harmful, as well as if there's any JavaScript void zero, skip, or hashtags in the flags of the anchors on the web page itself. And if a pop-up window occurs, that's probably obviously harmful as well. And so now we can move on to the reputation, which is just talking about how is the website interplayed with other websites on the web, how does Google itself see it? If you were to Google it, is it more of a safe website, or would it be considered as suspicious? And the features to look at for that would be to see if the web traffic has web traffic, to see if the website has web traffic going to it, seeing if it appears in Google, seeing if the website is pointed to by another website, seeing the PageRank, which was an algorithm written by Google, which ranks websites in a page 0 to 1. If a website is 0.2 or not, then it's usually closer to the scale on 0. So then that is really harmful, and just not because there's not that much web traffic going to it. And if the website is blacklisted or covered in other domains as well as being harmful, then it'll be automatically suspicious in a classifier as well. So if you do recursive feature elimination, you'll end up with the 5 most statistically significant coefficients. And if you just do that, then you'll end up that the most statistically significant coefficients are HTML that deals with the redirect, which is JavaScript void, anything that deals with skip or a hashtag. If the URL has 2 subdomains or more, which that means that there is a dot in the URL in places that shouldn't be, and that section consists of more than 3 of those sections. If the amount of web traffic to the website is negligent, or if there's nothing really going to it, then that would be considered suspicious, which makes sense that it's one of the most important statistically significant variables or coefficients. And if meta or script tags are on a website contain a URL, then that's also it's suspicious, so that makes sense. But if a website has a trusted certificate, that was seen as a statistically significant coefficient. However, it's pretty easy to get a cert if you're ever setting up a honeypot or some fake websites. So we'll go into that about how context really matters when you're evaluating your classification models, and how you can't just rely upon a recursive feature elimination or just going based on certain metrics itself. So if we just go on modeling, if you just use like the Thabta data set, you'll end up with something around a 95% accuracy with a 0.91 kappa statistic, which means that over 91% of the data is actually reliable and is better than just guessing at random. And then if you use a C4.5 decision tree, you also end up with a 97% accuracy, which means that 94% of the data is better than guessing at random as well. And these are really high accuracies and kappa statistics to evaluate the reputation of the data itself because of the categorical binary nature of the data. And so if you just use a naive Bayes, you'll end up with about 70% if you don't do any feature extraction, but then you can obviously increase your metrics with that. And so you can end up with about a 91% accuracy, and about that 85% of the data is reliable and better than guessing. As well, however, the data set does not really talk about if all these phishing attacks and campaigns are independent of itself. And a really important assumption in naive Bayes is that each category or row would be independent. So if the data set or the people who were to release this research were really talked about the independence assumption, and how maybe it's not just one attacker making a phishing kit, then that would make a much more relied upon assumption for a classifier. A neural network, just a basic RNN, shows about a 93% accuracy, and that almost 90% is better than guessing or not of the data. And then gradient boosting leans really well to binary and categorical data, because the classifier like GBM depends upon gradient boosted one-side sampling, which gets rid of any features that have a small information gain, as well as exclusive feature bundling. So if any features are mutually exclusive, then they are also taken out of the data set. So that makes sense that a classifier would have such a high accuracy, with 90% of the data being better than guessing. So just takeaways from modeling is that if you have binary categorical data of a really complex scenario, zeros and ones, then you're going to have really nice decision trees. You'll have really nice accuracies and metrics, but you also really need to think about how that'll play into the context of real life. Also, context really does matter with the recursive feature selection. You can have really important statistically significant variables, but if it's still pretty easy for an attacker to get a cert, then that's going to just mean that you need to really think about how your classifier is going to deal with more in the real world. And the future work that I would want to do is apply more of a visual analysis and textual analysis to the email repository that I'm building out. VirusTotal also is really important for malware analysis, and I think that would be really interesting if people were to make VirusTotal for phishing emails and have hashes associated with it, because these campaigns reuse some of their same techniques and the exact same email itself. So I think that would be a really important way for security analysts to kind of, as a community, get together and elaborate on work. And so the conclusions or major takeaways is that phishing repositories are incredibly underworked on as a resource. College phishing repositories are also underutilized, and that phishing detection should consist of both emails and the website itself that attackers are using to target people, as well as feature extraction for harmful websites should really be talked about and talked about what exact features we should be using. And thank you so much to David Reed for being a great mentor throughout this whole project, and the friends and mentors for support. And I'll be putting the scraper on GitHub in the next 2 weeks if anyone's interested in getting a scraper to have their own phishing repository research being done. And that's basically it. If you have any time for questions, just feel free.
Hi. Can you tell me a little bit more about why you chose the models you chose?
Yeah. So the models that I chose were
Can we go back and so I can see them? I don't remember them off the top of my head. I'm sorry.
Of course, yeah. Sorry about that. Yeah, so the models I chose, I wanted to get an array of different types of models. I wanted to really make sure that you start off with a decision tree or just rule-based learning, because I think you want to start simple. PCA was also involved in 1R to really just start off simple, but then I figured that'd be more interesting to put more of the more complex models as well in the research for the presentation. And obviously, like, naive Bayes is really different than gradient boosting, which is really different than a decision tree. And so I think it's just important to show that even with an array of different models, you can get somewhat similar metrics with the data set that itself.
Did you consider other neural nets instead of an RNN? Like, was that just kind of the one you went to, or what were the other options that you could have done?
For the other options, you definitely could have used a convolutional neural network, and that's part of the future work that is being done currently.
Cool.
Sure. So looking at this, one thing that I've always wondered is, how do you avoid the unsubscribe links? Avoid hitting those to, like, when you're processing through these data sets.
The unsubscribed links?
Yeah, so like if somebody received a legitimate email, it has an unsubscribe link at the bottom. Mm-hmm. If you're assessing all of these web pages that get processed from there, how do you make sure you don't unsubscribe people from mailing lists?
Well, most mailing lists would look really different, and so it would probably be kind of negligent to the classifier itself. So if you're being unsubscribed, then like a classifier would be able to see that, hey, this is different than the rest of the links on the mailing list.
Okay.
Wait, one sec. Yeah, just hand up, and then it's you.
Have you considered adding information from third-party sources as a feature, like the Google Safe Browsing API or Site Transparency Report?
Yeah, that's currently being added to the current work right now. That's a great point, that Google has its own analytics too that could be involved.
I was going to say, for the unsubscribe links, I'm pretty sure when you click unsubscribe, you usually have to input your email or something like that, so that I don't think just clicking it actually unsubscribes you. So that might not be a big concern. I was also going to ask, so we recently saw some ML-based malware detection software being able to be exploited because you could just append strings on the end and it would read it as like a whitelisted software. So what ways do you think an attacker could craft a malicious email that might be able to go around machine learning based phishing detection?
That's a great point, and especially really timely to add. However, I think that when you look at kind of news reports like that, you have to be aware that the data scientists are already aware that there is certain things like vanilla mimikatz or like the byte appending that you're talking about. That was something that people were already aware of and should have incorporated into the model. I think that all you can do is kind of have bug bounties for like the attackers or classifiers that you're working on, and just work with incorporating or improving your models itself as you get more feedback from people who are in more adversarial work.
So where do you see attack trends moving if this sort of technique, I mean, you're using it here as an undergrad, and you have a number of companies coming up with the millennial wave detection. Where do you see attackers moving to get around these defenses and so forth?
Yeah, I think a lot of that would be into the work that's being done with convolutional neural networks. If you look into any recent adversarial machine learning type of work, convolutional neural networks are a huge part because you can just change certain metrics, certain distances, certain hues in the image itself, and kind of add more static to break the classifier. Also, if you put anything that is similar to a input into a classifier but just change it slightly, then you could break the classifier in that way. So I think as more companies start putting ML into their phishing detections, then they're going to have to also think like, how are they going to break it visually and also in a type of text way, which would be really simple of just, hey, we can capitalize something that we don't have to.
Could you go back to the categories you had?
Yeah, of course.
Possibly. Like you had the 7 categories.
Yes.
Okay.
Yeah, I'm just getting
it's just
to it.
going
Microsoft
slow,
makes
going back and
garbage
forth. There it
products.
is.
Yeah.
How did you come up with these categories as? Did you cluster them, or did you kind of choose them based off of what you'd seen in the data?
I did it based off of what I've seen in the data. I think if you just kind of go based first on clustering and then kind of putting that into a context, then you can end up having some bias of reading clusters in the wrong way. So I really wanted to make sure of like looking into the research first and seeing what are the frequencies of the most prevalent type of attacks, and then coming up with these categories through that way.
Did you go through and then label the corpi from the educational sources this way and then run your classifiers, or did you have a different way of labeling the data?
So the data was labeled through a classifier. So, I first created these categories and then had a tag, and then I could assign those tags to the frequencies in the data.
Okay, thank you.
Yeah, my question was if you tried to actually do a multi-classification, a multi-class classifier given the different categories. So a one versus many kind of thing. Mm-hmm. I mean, maybe after you detect, it is a phishing, maybe you could run through some of these models. Just wondering if this is something that...
Yeah, that's currently being done.
Yeah, that's
sure.
super cool.
Yeah,
that should be super cool.
And more of the results will be released too eventually for that.
Thank you.
So whatever is left over after the classifier is by default there for the user to catch. And there's research showing that as these become more and more uncommon in people's email streams, they actually get worse at finding them. Mm-hmm. So in the face of very good technology that makes an attack email a very rare event, how do you protect a user who might see this so infrequently that they don't realize it's a threat? And how do you protect against the possibility that the actual number of compromised individuals doesn't change or even goes up?
Well, I think for your attack model, as this is becoming ever more important, you also need to have more education for your employees at an institution. You said that people are going to start looking at more emails like and not be able to tell the difference. But if you have like constant education as a security operations team, then you should have people who are mindful, because also part of like being a worker is also thinking about it. But if you're someone who like is at a corporation that doesn't have a security team and is much smaller, then you just have to probably stay vigilant to actually think like, hey, is this actually something that I should be clicking on or not?
Interesting. So you train your way out of people not seeing it in the wild.
That would be the best way to do it, probably, if you have the resources.
And then a corollary question to that is, when the classifier has identified phishing emails, what do you do? Do you tell the user? Do we mark it? Do we disable the URL? What do you think would be the best?
The deployment would be great if I were to put this into a different application and say like, hey, this is like phishing. This is just own research of just working on the classification part of it, not really the deployment.
Hi, awesome talk, by the way. I've heard that some scammers actually craft their emails poorly because like there's the probability of someone reading a poor email and actually clicking through, they'll be more likely to be a victim at the end or something like that. Have you actually like looked at the frequency of your emails to see like if there's a difference in distribution of like really well-crafted phishing emails and really poorly crafted emails?
Yeah, there's an index that kind of encapsulates that, and most of them are written pretty badly, but try to be written pretty nicely. So no one really tries to just like write garbage and then see if that works. But that would be great if that happened in a higher distribution. That would make things way more fun to look at.
Well, all right, let's give another round of applause.